Okay, I'm going to go over the solutions or just go over the lecture notes for section 1.1. So there's a blank copy online. And but I'm going to, in this one, I filled in the answer. So I don't actually have a whiteboard, so I'm just going to have to do it this way. And this is just review. A lot of you probably know most of this already. And if not, that's fine. But just we want to make sure and catch up as soon as we possibly can. So what's a function? So a function is just a rule that takes a value x to a value y. And x lives in the domain, and f of x is in the range. Okay, so the x, the domain variable is the independent variable, and the output y is the dependent variable. And the one thing that we know is that a function, every x can only map to one unique y. So you can look at a graph of a graph and see, oh, does that represent the graph of a function? And you just use the famous vertical line test. And if you can draw a vertical line through the graph, and if it intersects at two places, just at least one time, you know that it's not the graph of a function, because in that case, one independent variable x map, it gives two different outputs like that. That can be, it kind of looks like an ellipse. So we see that maybe zero, if x is zero, we get maybe, it looks almost like 1 and -1, maybe a little bit more than 1, a little bit less than -1. But we see that a lot of all the values x map to two different y's. So b cannot represent the graph of a function, whereas every x just maps to one value y. And then here are some of these. So here's some famous functions like y equals x, that's a line. Y equals x squared, that's a parabola. And so you're probably familiar with these, but I would definitely review the graphs of these. You can talk to me if you need some help, or use your graphing calculator, or go online and use a graphing application. So we know like 1 over x is a hyperbola. And then we have the famous trig functions, which we'll be dealing with a lot in this course. Okay, so now let's just look at another function, the square root of x plus 3. Okay, so what is the domain? So we want to make sure that the function is well defined. So if you put in, let's say like -4, well, then you're going to get the square root of -1. You can't do that. So we want to make sure that x plus 3 is positive or non-negative. So we just solve x plus 3 is greater than or equal to 0, or x is greater than or equal to -3. And in this case, the range, the square root can is just y greater than or equal to 0. So if you put x equal to -3, you get 0. And then you can get a number as big. You just keep making the x's, bigger and bigger and bigger, and you get bigger values of y. Okay, so now f of 1, well, just substitute x equal to 1, and you get the square root of 1 plus 3, which is square root of 4, which is 2. Okay, now C is function composition, which is an important concept. So wherever you see x, we're going to replace with x squared minus 3. So we're going to take the square root, f of x squared minus 3, which is the square root of x squared minus 3 plus 3, and you simplify. So don't leave the square root of x squared minus 3 plus 3. We always want to simplify. And you get the square root of x squared, and we can just simplify that as that's just the absolute value of x. Right, so you put -2 in for x, the output is going to be 2. Okay, so here's a more interesting problem. There are that example 3. So in this case, you have this function f of t is 28 minus 3t, but in this case, both t and f of t represent physical quantities. So t is seconds, and f of t is the amount of water in gallons. So we can't have negative seconds, and we can't have negative water. So we know that domain is, well, it can't be any less than t equal to 0. So it's t greater than or equal to 0. And we know the amount of water can't ever be negative. So we want to make sure we choose a t such that 28 minus 3t is greater than or equal to 0, and you solve for t. And so you get, you solve for t, you get 28 is greater than or equal to 3t, or 28 thirds is greater than or equal to t, or t is less than or equal to 28 thirds. So your domain, and because of the physical restrictions of the problem, is 0 to 28 thirds. If there wasn't these physical restrictions, it was just if I just said here's a formula, then the domain and range would be all real numbers. But because t is in seconds and the dependent variable is water, the domain is 0 to 28 over 3. And then And then when t is 0, we have f of t is 28. Okay, so when t is 0, you have 28 gallons of water. And when t is 28 thirds, you have 0 gallons of water. Okay, so we know that the range is going to go from 0 to 28. So let's do some more function composition. And so we have these two functions. The first one, f is a line, 4x plus 3, a line with an upward slope because f is, the slope is positive. G of x minus x squared plus 2x. So that's a downward facing parabola because the coefficient of the leading term is negative. And so f of 1, well, you just plug in 1 for x. So you get 4 times 1 plus 3. Well, that's 7. And then we want to, so we're trying to compute g of f of 1. So f of 1 is 7. And then g of 7 is minus 7 squared plus 2 times 7. So you get minus 49 plus 14, you get minus 35. Okay, so first compute f of 1, you get 7, and then compute g of 7. That's probably fairly, I'm going to guess that's fairly straightforward for a lot of you. But if not, don't hesitate. If I'm saying, I keep saying it's straightforward. If you're having a problem, don't hesitate. I really encourage you to contact me. You don't want to fall too far behind. Okay, so now we have to compute f of g of x. And so again, your g of x is minus x squared plus 2x. See, it's kind of hard to fit on the, I do have, you might want to open up a copy of yourself while you're looking at this, or print out a copy. And so just remember that f of x is 4x plus 3, and g of x is minus x squared plus 2x. So f of g of x, so for f, wherever you see x, you just replace it with minus x squared plus 2. So it's minus 4x squared plus 2x plus 3. And you just, multiply each term by 4, and you get minus 4x squared plus 8x plus 3. And again, we have a parabola. It's a parabola because the leading term is x squared. And it's a downward facing parabola because the coefficient of x squared is negative. And and it's in standard form. So the degrees are in descending order. And now we want to compute g of f of x. So again, so g of x is minus x squared plus 2x. Okay, so wherever you see x, you want to replace it with 4x plus 3. And so it's minus 4x plus 3 squared plus 2 times 4x plus 3. And then just, you have to make, important thing, students, is just simplify. You can't leave it like that. You want to, the final answer should be a parabola or a polynomial in standard form. So we just expand, we get, make sure you distribute the negative 1. So we get minus 16x squared plus 24x minus 9 plus 8x plus 6. And then again, simplify. You get minus 6x squared minus 16x plus 3. So again, it's a downward facing parabola. The leading polynomial is x squared. So it's a, the leading monomial is the leading term is x squared. So it makes it parabola. And the coefficient is negative, so it's a downward facing parabola. Okay, so now example 5. So f of x is x squared, and g of x is the square root of x minus 9. So we want to find the domain. So we can plug any number into x squared, right? You can square any number and you get a well-defined result. But the square root function, we can't take the square root of a negative number. So so for g of x, the domain of f is all real numbers, but the domain of g is just it's just x minus 9 greater or equal to 0, or x greater or equal to 9. So you put in negative, you put in 8, like g of 8, that'd be the square root of negative 1, which is not well defined. Okay, so now let's do some function composition again, and we're going to compute. Let's compute g of f of x. So f of x is x squared, and wherever you see x, you replace it with the square root of x minus 9. So it's the square root of x minus 9 quantity squared. You get x minus 9. But the problem is, okay, what's the domain? Well, x minus 9, you can put in any, you think you could put in any value like 8. But what happens, first you have to calculate g of x. So you're restricted to the domain of g, right? You can't put it, so once again, the domain is x greater or equal to 9. right? Because the first thing you have to do is you have to first evaluate the square root of x minus 9. And then you can apply f to that number. Okay, so when we do this function composition f of g of x, we're restricted to the domain of g. Okay, now let's do the other way around, g of f of x. Okay, so wherever we see x, we put g of x is the square root of x minus 9. And wherever you see x, you put x squared. So g of x squared minus 9 is, you get the, let me say it again. So g of x squared is the square root of x squared minus 9, but what's the domain? So once again, okay, so we could actually put in any value for x, g of x squared, the domain of x squared is all real numbers, okay? But g of x squared is the square root of x squared minus 9, and x squared minus 9 cannot be negative. So let's solve for that. So x squared minus 9 is greater than or equal to 0. X squared is greater than or equal to 9. And if you simplify that inequality, you get absolute value of x is greater than or equal to 3. So like if x is negative 4 squared is greater than or equal to 9. Or if x is 5 squared is greater than or equal to 9. But let's say x is 2, right? So 2 can't be in the domain because then you'd be evaluating the square root of 4 minus 9, which is the square root of negative 5. So yeah, so make sure, so g of f of x, the domain is absolute value of x greater than or equal to 3. Oh, students, here's my favorite problem in this section. Okay, so in case you're taking notes, okay. There's a few problems. I think there's a few problems like this in Math Excel. We want to calculate f of g of x. So g of x is x squared plus 3, and we want to find f, such that f of g of x is x to the 4th plus 6x squared plus 20. Okay, so in this case, so we're starting with x squared, and somehow we end up with x to the 4th. That means we must be squaring g of x, right? X squared is x to the 4th. So let's just let f be let's just, we'll assume that f of x is a second degree polynomial, which means it can be written in the form ax squared plus bx plus c. And now our goal is to find a, b, and c. Okay, and so wherever you see x, you substitute it with the function g of x, or x squared plus 3. So f of g of x is a of x squared plus 3 squared plus b times x plus 3 plus c, and then you expand, and that's going to be equal to x to the 4th plus 6x squared plus 20. So now you expand ax squared plus 3 quantity squared plus b times x plus 3 plus c, and you expand it, and what you get on the left side is ax to the 4th plus 6ax squared plus 9a plus bx plus 3b plus c, and that's going to be equal to x to the 4th plus 6x squared plus 20. Students, we make sure we combine like terms. Okay, in this case, it's not too hard because the only like terms are the constant terms. So it's and then write it in standard form. So we have ax to the 4th plus 6ax squared plus bx, and then 9a plus 3b plus c. And that's going to be equal to, we want that to be equal to x, that's the assumption. We want it to be equal to x to the 4th plus 6x squared plus 20. So now let's match coefficients. So the coefficient of x squared on the left is a. I'm sorry, the coefficient of x to the 4th on the left is a. The coefficient of x to the 4th on the right is 1. So a is equal to 1. And you can actually verify that. You can compare coefficients of x squared on the right and the left side. So on the left side, the coefficient of x squared is 6a. And on the right side, the coefficient of x squared is 6. So once again, you get 6a is 6, or a is 1. The coefficient of x on the left is b. The coefficient of x on the right side, there is no x. So the coefficient of x on the right is 0. So b is equal to 0. And now the constant term, we know that 9a plus 3b plus c is 20. So just solve for c. You get 9 times 1 plus 3 times 0 plus c is 20, or c is equal to 11. And so f of x is x squared plus 11. And I would actually recommend that you verify. Okay, so I should have checked my work and my answer, and I didn't. But why don't you go ahead and do that? So I'm saying if f of x is x squared plus 11, then f of g of x is x to the 4th plus 6x squared plus 20. So I'll do a better job of checking my work in the future. But definitely check your work to make sure that f of g of x actually is x squared plus 6x plus 20. Okay, so let's just talk about one. Let's go on here. Let's talk about secant lines. This might be a little bit new. Maybe I'm not sure if you have you've seen that term before. So if you take 2 points on a curve and you connect them with a line, that's called a secant line. And of course, to write the equation of line, you need a point and a slope. Or I mean, you can also have 2 points, but okay. So the slope of a line between 2 points, it's just rise over run. So y2 minus y1 or x2 minus x1. And you can write the equation point slope form. So that, just substitute y2 is just y and x2 is x. And so then you get that famous formula, the point slope form formula for a line. If you know, if you know a point on the line and the slope, we know that the equation of the line can be written as y minus y1 is equal to the slope m times x minus x1. Okay, so now let's see if we can, let's say we have this function square root of x, and we want to, okay, so we're going to draw a line that intersects the graph of the function at x equal to 1 and x equal to 9. Okay, so the square root of x is actually, that's the graph is the square root function. Okay, so let's just plug in. So what's the value of y when x is 1? So f of 1 is, the square root of 1 is y. When x is 9, the y value is 3. Square root of 9 is 3. Okay, so the square root function goes through 1 comma 1 and 9 comma 3. And now we're going to find an equation of the line that goes through 1 comma 1 and 9 comma 3. So let's just take the difference of the rise over run. So 3 minus 1 divided by 9 minus 1. So you get 2/8 or 1/4. And so I just plugged those numbers in. So y minus, so it doesn't matter which of those order pairs you use for in the equation of the line, it'll come out the same answer. So let's just use 1 comma 1. So so the slope is 1/4, and the line goes through the order pair 1 comma 1. So we have y minus 1 is 1/4 x minus 1, or I simplify that, or I solve for y. I get y is equal to 1/4 plus 3/4. So let's just verify again. I'm going to do a better job of checking my work next time. But look, you can try. This is simple enough. You can try this yourself. You plug in x equal to 1, you'll get y equal to 1. And you plug in x equal to 9, you'll get 9/4 plus 3/4 or 12/4, which is equal to 3. So you want to verify, and I should have actually written this out. You want to verify that your answer actually does go through, the line that you come up with really does go through 1 comma 1 and 9 comma 3. And just one other thing. Okay, so here's kind of this quotient that we see right there in example 7. You'll be seeing that a lot pretty soon. F of x plus h minus f of x over h. Let's just simplify that. And this will be kind of common, what we'll be doing. And let's see here. And I think something happened here to my writing here. Okay, so let's see. So let's just expand this. So f of x plus h is 2x squared plus h minus 5x plus h minus 1, minus 1. Yes, so wherever you see x, you're going to put x plus h. So f of x plus h is 2 times x plus h squared plus 5 times x plus h minus 1. And then we're going to subtract off x squared. So it's minus the quantity 2x squared plus 5x minus 1. And students, I have to apologize. Something kind of got erased here. Let's see if I can try this, see if I can put this in here. All right. Okay, so you, again, let's just simplify this. So we're going to expand the quantity x plus h, quantity squared. So you get, and then distribute the 2. So you get 2x squared and plus 4xh plus 2h squared plus 5x plus 5h minus 1, and then minus 2x squared minus 5x plus 1 all over h. And I think if I was really being exact, I'd make sure that this line goes all the way under. And again, let's just simplify that. And notice all the terms that don't involve h kind of just drop out. Minus 2x squared minus 2x squared, 5x minus 5x, and then minus 1 plus 1. So what we're left with in the denominator are just the terms involving h, 4xh plus 2h squared over 5h divided by h, and simplify. And so what we come up with is the expression 4x plus 2h plus 5. So students, look at the original function. It's 2x squared plus 5x minus 1. And pretty soon soon enough, we're going to be talking about something called a derivative. Somebody might already know what a derivative is. So look at that 4x. So look at 2x squared. How did you go? See how we went from 2x squared to 4x? So what we did is we subtracted 1 from the exponent. We multiplied the exponent by 2 and subtracted 1 from the exponent, right? See if I can try this. It's hard for me to write sometimes on the screen here. And so what do we want? 2 times 2, x, 2 minus 1. Sorry, I know this printing is pretty bad. We get 4x. And so notice that, and the same thing for the 5x. We just subtracted, the exponent was 1. So, and I think I'm going to, the screen's jumping. I apologize about that, student. So, where did that go to? So you went 5 minus 1, x 1 minus 1, and what do you get? 5, just 5. And we're going to be doing that pretty soon. So if you actually substitute, so our final answer is 4x plus 2h plus 5. If you substitute h equal to 0, you're going to end up with 4x plus 5. And that's soon enough, we're going to be learning that's our derivative. And we're going to learn simple rules. So here we actually, had to do, we had this difference quotient. We had to simplify it. But pretty soon we're going to learn these simple rules for calculating a derivative, but nothing to worry about right now. Okay, so that was kind of bonus material. Okay, so students, I'm almost done here. So the average rate is just the difference, of the dependent terms over the independent terms. So in this case, if we're dealing, the average rate is, let's say, when the independent variable is in terms of time. Okay, so we have this function, the volume of a balloon is 2 times the cube root of t, where t is in seconds. So we'll just, and we want to know the average rate of change with respect to time over the interval from t equal to 1 to t equal to 8. Okay, so we just take the difference of the volume divided by the difference in the time. So it's v of 8 minus v of 1 over 8 minus 1. Well, v of 8 is, the cube root of 8 is 2. So v of 8 is 2 times 2, which is 4. V of 1, well, the cube root of 1 is 1. So v of 1 is 2. So it's just 4 minus 2 over 8 minus 1. Okay, so the average rate is 2/7 per second. That doesn't say that, when it says volume, doesn't say what, like if it's what the measure is. Okay. And one other thing. You might want to just read this. There aren't any problems here, but we talk a lot of, we're going to talk more about, you probably talked about even and odd functions in trigonometry, like the cosine is an even function, the absolute value of an x is an even function. So the function is, a function's even if the graph is symmetric about the y-axis, or f of x is equal to f of minus x. And a function is odd if f of minus x is minus f of x. In that case, the graph is symmetric about the origin, or you can rotate the graph 180 degrees and the graph doesn't change. So like sine of x is an odd function.